Welcome to the first Jones Seminar Speaker of the year. We're quite fortunate today to have Dave McQueeney, who it turns out actually was not only an alum of Dartmouth, but took many courses down here at the Thayer School of Engineering a couple of years ago. So I'll just tell you a little bit about him. He's presently the Chief Technology Officer for IBM's U.S. Federal Government Unit. I think that the blurb that went out implied that he was of the entire IBM, but he has a specific role. And his background covers a wide range of disciplines, from solid-state physics to high-speed interconnect design to distributed software development tools. He's held a number of rather significant positions in IBM research, including director of the IBM Zurich Research Laboratory, of which many of you have probably heard. He's been Vice President of Communications Technology and Vice President of Technical Strategy and Worldwide Operations. He's published in a wide range of topics, from liquid helium physics, advanced electronic packaging, high-speed interconnects, and the evolution of research in the commercial environment. He joined IBM in the research division in 1988. He holds an MS and a PhD in solid-state physics from Cornell University and an AB in physics from Dartmouth College. He was recognized as one of the Fed 100 top leaders in the federal community for 2006 by Federal Computer Week magazine. Please welcome Dave McQueeney.
Well, thank you, Ursi. You did promise to read 2 sentences instead of the whole thing, so you get a demerit for that. You crossed. Okay, all right. Thank you very much for the invitation to be here today. It's a pleasure for me to be here. If it in some way pays a debt to Dartmouth or to Thayer School, then all the better. If I had one regret about the time I spent here, it's that even as a physics major, I didn't spend more time down here in the engineering school, because what some of you who are still studying will find, and I'm sure some of you who are further along in your careers already know, there's a relatively small chance that throughout your career you'll stay exactly in the same technical field that you studied even as a graduate student. It's a happy coincidence when it happens. I'm jealous of those colleagues who have that, but for I think most of us, we'll end up moving around and sampling different fields. And so the things that you learn as an undergraduate and as a graduate student that you will value the most, more than the specific knowledge, which quite frankly you can gain somewhat on your own if you need to, are the insights from a career of work and the insights from someone who's thought deeply about a profession. And so when I think back on the things I cherish most that I learned, actually not in this building since it wasn't here, but the building next door, it was the insights from people like Professor Stratton about analog circuit design and other professors here at Thayer School about, again, not so much the specific knowledge, but about how to think and how to approach problems and how to do engineering when it went beyond the individual person to the team, where essentially, most industrially meaningful work is done. That may be less true in academia, where you can still make a lot of progress as an individual. And if coming back here and offering a few insights is in some way a small repayment of that, I would be very happy. The topics I've selected for today cover a couple of areas. So I'm going to start out with a little bit of context setting to put you in the perspective of the role that I play for IBM so you can understand where I'm coming from. So the title of Cto of Ibm Federal basically means I'm 100% dedicated to working with IBM's clients that are part of the U.S. federal government. And one of the things that is interesting about our federal government is they tackle problems of a complexity and a depth and a scale that is beyond almost anything we see in other governments around the world or in our commercial clients. And so they are truly solving some of the hardest technical problems that we know of. They get a lot of publicity when they stub their toe or drop a ball, and they get criticized a lot for programs that fail. And perhaps some of that is deserved, but I would encourage all of you to look a little bit deeper the next time you read one of those stories and look at the magnitude of the problem that was being attempted. And it's typically the case that something about that problem has never been done before. And in fact, when you started the problem, it would fit into my definition more of physics than engineering. And I would often say that, you know, physics research, a lot of times, you're doing the research to determine if something is possible at all. And it is usually the case in an engineering project that you know that the thing that you seek to do is possible from a kind of a fundamental physics point of view. The challenge is, can you execute that with the resources you have? Can you meet the budget? Can you meet the time commitment? Can you meet the quality constraints? Can you meet the usability constraints? And those are you know, capital H hard problems, as my son likes to call them, just as much, but it's a different mindset. And so a lot of the programs that are described as engineering programs in the federal government are in fact science programs, because it's actually not known at the outset of the program if the problem is even possible to solve. So I'm going to start out with a couple of charts. Well, before I do that, so the Cto of Federal, what is that? So as IBM brings its standard product offerings to the federal government, we can sell them databases, we can sell them messaging system, we can sell them system management and security management, we can sell them servers, we can sell them installation and customization of SAP systems as a service delivery. And certainly our federal government consumes a lot of the same things we sell to our commercial customers. But they also require us to do special federal certifications, special security features, to deliver things under very specific contract terms and conditions, to configure systems in unusual ways, to provide technical people that hold security clearances that can get into some sensitive spaces and do perhaps what's ultimately similar technical work to what we do elsewhere, but embedded inside of a system that the government doesn't want the details of, you know, known outside of a need-to-know community. And so what we found in IBM was, yes, we could sell our commercial offerings to the federal government, and that could be a good business, but with a modest size investment. In our case, for the federal CTO team, it's about 60 people. So we've got some IT architects, some IT specialists. We've got a small data center with a pretty good sampling of current technology from IBM and some other companies. We can then use that group of 60 people on the ground in Washington as an interface to bring all of the deeper technical capabilities from IBM Research, which is about 3,000 people, or the IBM development community, which is many tens of thousands of people, and we can adapt and customize and bring that value in addition to what we can do with our products. So that means that this particular job that I enjoy now has a lot of the things that I've always enjoyed. One is it's got a very strong customer-facing component. I spend most of my time meeting with our clients, discussing their technical problems, and determining to what extent our capabilities can address those problems. I've got a technical team of folks. I enjoy building, developing, advancing, you know, the careers of the technical folks that I work with. And it gives me a sense that we have enough of a group, enough of a critical mass to do things that are meaningful. We can go home at the end of the day and feel like we moved something forward in a significant way. I can remember especially fondly the day we had invested about 3 years of effort. Before the government had actually bought a system, we'd invested a lot of work in prototyping it, and it was a system inside the intelligence community, and the prototype system was working on copies of real data feeds, but that were not connected to the live system. They were yesterday's data and last week's data, and looking for certain events in the data. And the system worked well enough that one day one of our partners from one of the big system integrators called us and said, you know, we got so excited about the system, the prototype you delivered us, is we unhooked the feed from the fake data and we hooked the feed up to the real data, and we put the analysts in front of your system, and I just wanted to let you know that there's about half a dozen people alive today that wouldn't have been if we hadn't taken that prototype system and plugged it into the live data. So when companies like IBM talk about a corporate value of innovation that matters, I don't think it gets a lot better than that. That was a pretty good day. Of course, it would have been better if those people hadn't been in harm's way in the first place, but given that they were, and something we were able to do kept them out of that trouble, it was pretty rewarding. So that's what the federal CTO team is about. I don't know, let's see, this is late last year. A publication called Defense Daily sponsored something called an Open Architecture Summit, and they invited a bunch of folks to come and speak. And so I gave the opening presentation on the first day of the conference.